Hey, Swati here. Welcome back to Python, Zero to Expert. Last time we met property-based testing. Today we get our hands dirty. A full, real walkthrough. We'll start with an empty folder and end with a test that finds a bug, hiding inside a sequence of actions. No slides. We build it together. Here's the twist we're chasing. Some bugs don't live in a single input. They only show up after a particular sequence of actions. Deposit, then withdraw again. Stateful testing hunts exactly those. Let's build a bank account and catch one. First, the picture. Think of a vending machine. Press one button, it works. But press coin, refund, buy in some odd order, and suddenly it hands out a free drink. Each action was fine alone. The bug lived in the order. Regular tests check one action at a time. Stateful testing lets hypothesis press the buttons in thousands of different orders, looking for the sequence that breaks you. Let's set up for real from nothing. Make a folder and step into it. Create a virtual environment that keeps this project's packages to itself. Activate it, and notice the prompt now shows .virtual environment. Then install our two tools, pytest, the test runner, and hypothesis, the property engine. One-time setup, done. Two files, that's it. Bink.pp holds the code we're writing. Testbink.pp holds our tests. Pytest will find that test file automatically. Just by its name, let's write the code first. Here's the whole account. Nothing hidden. It starts with a balance of 0. Deposit adds money. Withdraw takes it out. But look closely at that guard. If the balance is above 0, subtract the amount. It looks careful, doesn't it? Hold that thought. We'll come back to it.
Liam here. Read that withdraw guard again. It checks that the balance is positive, but it never checks that you have enough for this particular withdrawal. That's the kind of almost right that slips through a code review. Let's see if a test can catch what our eyes didn't.
Now the test you'd naturally write. Import the account. Make 1, deposit 100, withdraw 30, and check the balance is 70. Totally reasonable. This is the single case you thought of. Run pytest. 1 passed, green. And honestly, most of us would stop here and ship it. But think about what we proved. Deposit, then 1 withdraw, in that exact order. That's a single path through the code. Real users do these actions in every order imaginable, and we haven't tested a single other one. So instead of scripting one path, we describe the actions and let hypothesis drive. This is a rule-based state machine. Each method marked as a rule is an action. Hypothesis can take, deposit an amount, or withdraw an amount, both small positive numbers. And the piece marked as an invariant is the promise that must hold after every single step. The balance can never go negative. That last line hands the machine to pytest as a test. We wrote no sequences ourselves. Hypothesis will invent thousands of them. Run it! And hypothesis fails, but look how it fails. It hands you the exact sequence, make an account, deposit 1, withdraw 2. Now the balance is -1, and our invariant screams. There's the bug we stared right past. The guard only checked that the balance was positive, not that we had enough for this withdrawal. So a small deposit followed by a bigger withdrawal sails through. And here's the beautiful part. Out of thousands of random sequences it tried, hypothesis shrank the failure down to the 2 smallest steps that still break it. The fix is now obvious because hypothesis told us exactly what's wrong. Guard the right thing. Only withdraw when the amount is less than or equal to the balance. One line, but we'd never have trusted it without a test that actually tried to overdraw us. Sarah here. Run it again, and both tests pass. and that second one just quietly threw thousands of random deposit and withdraw sequences at your account in every order, and every single one kept balance safe. That's the confidence stateful testing buys you. In real projects, this is how people test carts, queues, caches, and databases. Anything where the order of operations can bite. And that's stateful testing, built from an empty folder in one sitting. You described the actions. Hypothesis tried them in thousands of orders, found the sequence that broke your invariant, and shrank it to 2 tiny steps. Rule of thumb: whenever the order of operations matters, don't script one path. Describe the rules and let the machine explore. I'm Swathi. This is Codecraft. See you in the next one.